All right, so Unit 4, Lesson 1 is our Intro to Logarithms. It's what undoes exponents. So real quick, let's look at the graph y equals 2 to the x. So if I were to graph it, we know 2 to the 0 is 1, 2 to the first is 2, 2 second is 4, we got 2 to the third is 8, and then we know it goes off into very close to the x-axis. Great. So since a logarithm is what's going to be the inverse of an exponent, let's take the inverse of this graph right away. Well, that's really easy to do. If this is the point 0, 1, we know that the inverse is 1, 0. If this is the point 1, 2, we know the inverse is 2, 1. That's 2, 4, the inverse is 4, 2. And then our last one, where the inverse of 3, 8, would be 8, 3. Now, since this exponential graph gets very close to the x-axis, the inverse of that would be getting very close to the y-axis, but not really touching it. So there is our new graph. And remember, inverses are always flipped over the line y equals x. So now, just to summarize so you can see it, the asymptote of an exponential graph is always y equals 0. So the asymptote of its inverse, if we switch x and y, that means that y will be switched to x. The domain. The domain is what values can be put into an exponential graph. Well, every x can be put into an exponential graph. So you could either write all reals, or you could say every number from negative infinity to infinity. What about the range? Well, when we look at the range of an exponential graph, we notice that it never comes here into the negative zone, right? That's because we have our asymptote. So our range is the number after 0 all the way to positive infinity. Well, now, if logarithm means to switch x and y, then it's very easy to do our domain and range here. Well, let's look at our domain. Our domain for our exponential graph, notice I did not put in any negatives over here. So I can only put in numbers greater than 0 all the way to positive infinity. Hey, get it? Switch x and y. So I guess you can see right now that the range of our logarithmic graph would be the domain of our exponential graph, which means this blue graph will pass every number in the world, or it will go through every negative to positive number in the world. So remember, we take the inverse by switching the x and y values, thus flipping over the line y equals x. So if I was going to write this as an equation, well, that's going to look weird because originally we had y equals 2 to the x. Okay, we're going to flip x and y because that's what we do when we take inverses. So x equals 2 to the y. Okay, that was easy, but what's the equation? All functions have to be solved for terms of y because y is the output. We always want to see the output that we get depending on the input. And that is where you're going to learn your new operation. All right, so let's start slow here. Let's look at an easy example. 2 to the 4th is 16. That's a fact. Now over here, I have my list of operations. We know that if we add, the inverse is subtract. We know that if we multiply, the inverse is divide. We know if we take a square root, the inverse is squaring it, and vice versa. And in fact, if you look on your calculator, everything is written in inverse form, starting with the on-off button, on and off. And when we come over here, plus and minus are right next to each other. divide and multiply are right next to each other, and they get their own keys because they're used so often. But I'm going to come over here and we're going to look at squared and square root. Look, they're on the same key because they're inverses of each other. And this is what you're learning today. Log, and see what's above it? 10 to the x. An exponent, and log undoes exponents. So the inverse of an exponent can be written in logarithmic, ooh, there's a big word, form as log 216 equals 4? What does that mean? Well, first of all, let's get this straight. We abbreviate logarithmic as log. And you saw that on your calculator. There's no way we can fit the word logarithmic on your calculator, so it's considered log. And, logarithmic is just a Greek word, and we'll get into that tomorrow. So, upon a further investigation, logarithm is a fancy Greek word, like I said, for exponent. So we've got to figure out what this log, and that too is important in the base. It is written as a subscript, not a superscript and not online. But let's break this down. Log in red. We really read it as what is the exponent? This 2 in green now is a base of 2. See, this is a base that gets us 16. Why, the answer is 4. So notice what I said here. This is the most important. This is the base, and base means bottom. So remember back in grade school when you were learning how to write and you had this paper and you had the dotted line in the middle and your teacher was teaching you how to write, and you would keep your letters. Well, when I'm writing log, it's a word, but this 2 is definitely below. It's a subscript. That is the hardest part for kids to do. They always want to write this because they get the idea that we're exponents, but no. Wipe that from your mind. Make it like I never wrote that. We have to teach ourselves to read this as what is the exponent of base 2 that gets me 16? Why, the answer is 4. I know that's a lot, but that's what we're going to work on today. All right, so we're going to just practice writing this exponential equation as its inverse, as a logarithmic equation. So we're training ourselves to say, this is really read as, over here, what is the exponent of 2 that gets us 64? Well, this is the easy one to do. No one ever messes up the base. We understand that the base of an exponent is the base, the bottom of a logarithmic. So what is the exponent of 2 that gets us 64? Well, the exponent of 2 that gets us 64 is 6. All right, so let's go on to a more abstract one where we don't have an actual numbers, but we have variables. So once again, this logarithmic is read as what is the exponent of a that gets us 1 over a? All right, so what is the exponent of a that gets us 1 over a? Well, the exponent is -1. What is the exponent of 3 that gets us 81? What is the exponent of 3 that gets us 81? Well, here the answer is x, but you could see now that you could figure this out. This is a pretty easy one. What is the exponent of 3 that gets us 81? X is 4.
Now I want to also note something here. We often have read this wrong. If you're in class and I asked you to read this, most of you would say 3 to the x power is 81. And that's something I wish we would address and we would stop saying it. I say it all the time too, but we as math teachers really should address this early on. This should be read 3 to what exponent gets me the power 81, because 81 is a power. In other words, 3 to the 0 gives me a power of 1. 3 to the first gets me a power of 3. 3 to the second gets me a power of 9. These are all powers of 3, meaning they were obtained by multiplying base 3 together multiple times. And that is something we are going to have to teach our brains that, you know what, we've been saying this wrong all along since we learned exponents probably in 6th grade. Once again, train your brain. That's what learning is all about. How about going backwards? Log 49 1/7. Let's see if we can do this without having to ask ourselves a question. Well, 49 is the base, so we know 49 is going to go here. And we know that this is the power. And we're looking for the exponent. What is the exponent of 49 that gets us 1/7? All right, well, how does 49 and 7 relate? Oh, it's a square root. And how did it turn to 1/7? Oh, it's a negative. Here they actually gave us the equal sign. Up here we didn't. Get it? This was an equation. This is asking us to solve what is the exponent of 49 that gets us 1/7. Well, we figured out that exponent is negative 1/2. Here the base is unknown. All right, so if I were to rewrite this, b is base. So b, 27, well, that's my power, and this is my exponent. Okay, so if I were to read this, it is saying, what is the exponent? Remember, what is the exponent is a fancy phrase for log of base b that gets us 27. B to the third gets us, so what must that base be? Oh, that base must be 3, because 3 to the third gets me 27. All right, B, well, that's a base. 5 is a power. And 1/4 is an exponent. Ooh, this is a really tricky one. What is the exponent of b that gets us 5? So they're asking me some number raised to the 1/4 gets me 5. Well, I know a way to solve this. I know that I can neutralize this exponent up here. How do I undo? Here go our inverses again. How do I undo a 4th? By raising it to 4. But what I would do to one side, I must do to the other. These cancel out. So b ends up being 625. And that makes sense. 625 to the 4th power means 4th root. So what is the 4th root of 625? 5. So in summary, what did I want you to learn in this lesson? That logarithm really is a fancy word for exponent. That when we see log of base b x is y, we want to train our brains to read it as, what is the exponent of b that gets us x? See, we're trying to find the exponent. And we need logarithms to solve equations where the exponent is